B.Sc SY Physics Semester 3rd Unit 1st Statistical Basis and Thermodynamics. Hello student, welcome to all of you. In previous period we had studied permutation. What is permutation? First of all we define the permutation, the number of arrangement of undistinguishable object by taking R at a time is called permutation. Again, we repeat the definition, the permutation. We also define shortly, permutation is the number of arrangement. The number of arrangement of undistinguishable object by taking R at a time. They can be written in mathematically NPR, that is equal to n factorial divided by n minus R bracket close factorial. For example, 4 distinguishable object taking 2 at a time. 4 distinguishable object A, B, C and D taking 2 at a time. In this case, n is equal to 4 and R is equal to 2. Put in this above formula, we get 4p2, that is equal to 4 factorial divided by 4 minus 2 factorial, that is equal to 4 factorial divided by 2 factorial. The meaning of 4 factorial is 4 into 3 into 2 into 1 divided by 2 factorial is 2 into 1. Cancelling 2, we get 12. The number of permutation is 12. Dear student, never stop learning. What is the meaning of life? The meaning of life is first, to grow; second, to learn; third, to change with time; so fourth, keep windows of your mind open. Today I am going to discuss on combination. What is the meaning of combination, or what is the definition of combination? Combination is shortly the number of group is called combination, or the number of group, that is meaningful combination of undistinguishable object taking R at a time, that is called combination. In mathematically, NCR, that is equal to n factorial divided by R factorial in bracket n minus R factorial. For example, the meaning of combination, the combination of an object, 4 object A, B, C, D taking 2 at a time, AB, AC, AD, BC, BD and CD. That is only 6 combination which are symbolically represented as 4C2, that is equal to 4 factorial divided by 2 factorial into 4 minus 2 factorial, that equal to 6. Similarly, the combination of 4 object A, B, C and D taking 3 at a time, taking object 3 at a time, that is ABC, ABD, ACD and BCD. Only 6 combination which are symbolically represented as 4C3 that is equal to 4. In general, lastly, the summary of the combination is the number of groups, that is meaningful combination of n distinguishable object by taking r at a time, is given by NCR, that is equal to n factorial divided by r factorial into n minus r factorial. This is the mathematical statement of combination. The next article today, in this period, we learn about macrostate and microstate. Dear student, everything has its own beauty, but not everyone can see. Dear student, what is the truth of life? The truth of life is, do a million good things, nobody will care. Commit a single mistake and everybody will judge you. This is the truth of life. The next article is the macrostate and microstate. First of all, we define macrostate. Each compartment wise distribution of a system of particle is called as macrostate. Consider 4 distinguishable particles and A, B, C and D. These are the number of 4 distinguishable particles. The distribution of these particles into 2 exactly similar compartments in an open box as shown in table. The compartment is also called as cells. Let the particle be A, B, C and D. When any particle is thrown into the box, it must fall into one of the 2 compartments. The possible ways in which 4 particles can be distributed in 2 compartments are as shown in following table. In this table, suppose compartment is called cells. There are 2 compartments, 1 and 2. The number of particles are 4, A, B, C and D, and there are 5 different distribution, 1, 2, 3, 4 and 5. They can be written as the probability of going into either of them will be half. There are 5 different distribution. Distribution 1 can be written as 0, 4. Distribution 2, 1, 3. Distribution 3, 2, 2. Distribution 4, 3, 1 and 4, 0. In general, for a system of n particle, the macrostate are 0, n bracket close, 1, n minus 1, 2, n minus 2, n minus 1, 1 and n, 0. Therefore, the total number of macrostate for n particle is n plus 1. This is the description about macrostate. The table indicates that the 2 compartments or 2 shells, 1 and 2, the number of particles is 4. The different distribution is 0, 4, 1, 3, 2, 2, 3, 1 and 4, 0. These are the different distribution that is called macrostate. And let us discuss on the microstate. First of all, we define the microstate. Microstate can be defined as each distinct ion arrangement is called as microstate of the system. Since the particles are distinguishable, the number of different possible arrangement in each compartment is as follows, as shown in table. Macrostate is also called as different distribution. The first different distribution 0,4 can have the arrangement 1. The number of microstate is also called as thermodynamic probability. The first step is 0,1 distribution can have the arrangement, possible arrangement is 1. The distribution 1,3 possible arrangement is 4. The distribution 2,2 can have the possible arrangement is 6. The distribution 3,1 can have the possible arrangement is 4. And last distribution 4,0 can have possible arrangement is 1. In this table, we conclude that there are 5 different distribution is called macrostate, and the number of microstate is called thermodynamic probability. The number of microstate, total number of microstate is 16. 1 plus 4 plus 6 plus 4 plus 1, that gives 16. The distribution 0,4 can have only one arrangement. The distribution 1,3 can have 4 arrangement. The distribution 2,2 can have 6 arrangement. The distribution 3,1 can have 4 other arrangement. Distribution 4,0 can have only one arrangement. Thus, a given macrostate may consist of a number of microstate in above example of 4. The total number of microstates are 16 is equal to 2:4. In general, for a system of n particle, the total number of microstates are 2:n. Suppose we consider a thermodynamic system of n identical, non-interacting particle occupying a volume phi. Let E1, E2, E3 EI be the number of energy of the particle, and N1, N2, N3 N are the number of particles respectively. The total energy of the system is E is equal to N1 E1 plus N2 E2 plus N3 E3 plus N4 E4 Ni into EI, that equal to summation of Ni into EI, and capital N is equal to summation of small ni. The actual values of parameters of n, phi and E define a particular macrostate in bracket n, phi, E of a given system. Lastly, dear student, we can say that first of all, some thoughts are given you, a lesson from our hand. all fingers are not in the same length, but when they bend, all stands equal. Life becomes easy when we bend and adjust all situation. Thank you so much.